July 1st, 2025, Rio Hurtado, Chile. The Atlas telescope picks up something moving, not just moving, screaming through space at 209,000 kilometers per hour. Within 24 hours, astronomers confirm what the trajectory tells them. This thing came from outside our solar system. Third interstellar visitor ever confirmed. Bigger than the others, faster than the others, and within days, the internet explodes with one question. Is it alien technology? Closest point to the sun at 1.4 astronomical units, right between Earth and Mars. But here's the thing nobody talks about. That same day, it disappears behind the sun. Solar conjunction on October 21st, 8 days before perihelion, the comet goes dark from Earth's view. And suddenly, everyone's asking the same thing. What if it does something while we can't see it? This script is researched and factual, using sources from NASA's official science pages published between July and October 2025, peer-reviewed research from the James Webb Space Telescope team published in August 2025 through the Archive preprint server, and directed statements from Tom Statler, NASA's lead scientist for solar system small bodies, reported in The Guardian in September 2025. These aren't generic space websites. These are primary sources from the teams actually observing the object. Now back to the information. The myths spread fast. Forums light up. Social media explodes. Harvard professor claims 30 to 40% chance it's not natural. Suggests it might perform an Oberth maneuver while hidden. Release mini-probes. Change course. Attack Earth. The speculation builds on itself. Each claim more alarming than the last. But here's what actually happened when scientists pointed every available telescope at 3I Atlas. And here's why almost every expert in the field calls the alien hypothesis nonsense. The idea sounds plausible at first. Spacecraft falls deep into a gravity well, fires engines at maximum velocity near perihelion, uses the sun's gravity to amplify the thrust, gets way more speed change than burning fuel in deep space. It's real physics. Hermann Oberth figured it out in the early 20th century. Voyager used it, New Horizons used it. But there's a problem with applying it to 3I Atlas. The comet would need engines. Force times distance equals work. At high speed near perihelion, the same burn moves you farther during the same time. More distance means more work done, more kinetic energy gained. It's not magic, it's just physics. But it requires propulsion, a rocket engine, something that burns fuel and produces directed thrust. And 3I Atlas shows zero evidence of any propulsion system whatsoever. Used the near-infrared spectrograph instrument. The spectrum shows carbon dioxide dominating the coma, 8-to-1 ratio of carbon dioxide to water, one of the highest ratios ever recorded in any comet, plus water ice, carbon monoxide, carbonyl sulfide, all detected through spectroscopy. Not speculation, direct measurement of molecules, published in a NASA preprint on August 25th, 2025. Found a massive carbon dioxide gas cloud extending at least 348,000 kilometers from the nucleus. Detected water ice in the nucleus itself. Both observations consistent with exactly one thing. A comet outgassing because the sun's heat is sublimating its ices. Not rocket fuel, not controlled burns, just ice turning to gas because that's what ice does when you heat it up. Constrained the nucleus diameter to somewhere between 440 meters and 5.6 kilometers, most likely less than 1 kilometer across. The European Space Agency's Mars orbiters caught it on October 3rd. Mars Express and ExoMars Trace gas orbiter both photographed it at 30 million kilometers from Mars. Extremely faint, up to 100,000 times fainter than typical targets, but visible, and behaving exactly like a comet should. Here's what 3I Atlas didn't do during solar conjunction. It didn't change velocity in any way inconsistent with gravity and outgassing. It didn't release objects. It didn't maneuver. It didn't send signals. It followed the exact trajectory predicted by celestial mechanics. When it emerged from behind the sun in mid-November, every telescope that could see it confirmed the same thing. Still a comet. Still outgassing, still following a hyperbolic escape trajectory with no course changes. Tom Statler, NASA's lead scientist for solar system small bodies, told The Guardian in September 2025, "It looks like a comet. It does comet things. It very, very strongly resembles in just about every way the comets that we know. It has some interesting properties that are a little bit different from our solar system comets, but it behaves like a comet. And so the evidence is overwhelmingly pointing to this object being a natural body." The claim goes like this. 3. I-Atlas approaches within 5 degrees of Earth's orbital plane, passes relatively close to Venus, Mars, and Jupiter. The combined probability of such a trajectory is only 0.005%. Therefore, it must be deliberate. Therefore, alien probe. The math looks compelling until you check it against reality. The galactic disk is only about 1,000 light years thick, but 100,000 light years across. Objects formed within stellar systems in this disk naturally tend toward planar orbits. 3. I Atlas likely originated from either the thin disk or thick disk of the Milky Way. A September 2025 study by Yi-Young Guo found it may have passed within 1 parsec of 25 known stars in the past 10 million years. Its trajectory reflects its galactic orbit, not intelligent planning. The probability calculation cherry-picks which planets matter. Why Venus, Mars, and Jupiter? Why not Mercury, Saturn, Uranus, Neptune? Why not the thousands of asteroids? The math only works if you decide ahead of time which encounters count as significant. That's not how probability works. That's retrofitting data to match a conclusion. Multiple astrophysicists, including Scott Manley and David Kipping, pointed out flaws in this statistical analysis immediately after the claim appeared. Every specific configuration of atoms in your body right now has an astronomically low probability. Every specific hand of cards dealt has odds of 1 in 80 billion trillion. Yet cards get dealt. Bodies exist. Low probability doesn't equal impossible. And it definitely doesn't equal artificial. It reached perihelion on October 29th at 1.4 astronomical units. That's 210 million kilometers from the Sun, just inside Mars' orbit. Then it heads back out, passes Jupiter's orbit in March 2026, gone forever. 1.8 astronomical units, about 270 million kilometers, almost twice the Earth-Sun distance. Never a threat. Never close. NASA confirmed this on their official science page, updated through October 2025. The comet poses no danger to Earth and will remain far away. Not a carefully aimed probe, just a piece of another star system passing through. Live Science reported in July 2025 that many researchers were disappointed with the new paper and pointed out that it distracts from the work of other scientists. 3. I Atlas really does have weird chemistry. The carbon dioxide to water ratio is genuinely anomalous, 8 to 1 compared to typical comets. Plus, it started out gassing way earlier than expected, active at 6.4 astronomical units from the Sun in May 2025. Most comets don't get active until inside Jupiter's orbit at 5 astronomical units. And then there's the nickel. Never seen in solar system comets at these concentrations. James Clerk Maxwell Telescope found hydrogen cyanide on September 7th. Production rate of 1.5 times 10 to the 25th molecules per second. Also unusual but not unprecedented, so the chemistry is weird. But weird doesn't mean artificial. That's the distance where temperatures drop low enough for carbon dioxide to freeze solid. Different star systems have different ice lines, depending on the star's temperature and the protoplanetary disk's composition. A carbon dioxide-rich comet just means it formed in a cold region of its home system. They noted the comet may have been exposed to higher levels of radiation than solar system comets. Cosmic rays and stellar radiation can preferentially strip away more volatile ices like water and carbon monoxide, leave behind a carbon dioxide-rich mantle. Over billions of years, this changes the surface composition without changing the fundamental nature of the object. Water ice doesn't sublime significantly until much warmer, so a carbon dioxide-rich comet naturally starts out gassing farther from the Sun. Exactly what we observed. NASA's Transiting Exoplanet Survey Satellite caught 3. I Atlas already active on May 7, 2025, at 6.4 astronomical units out. Not mysterious, just carbon dioxide doing what carbon dioxide does. Astronomers learned 5 years ago that comets normally emit nickel. It comes from volatile nickel compounds like nickel tetracarbonyl. These form in cold, carbon-rich environments, break apart when heated, release nickel atoms that glow under ultraviolet light from the Sun. The concentration in 3 I Atlas is higher than usual. But higher concentration doesn't mean artificial origin. It means different formation conditions in a different stellar system. Stephen Desch, astrophysics professor at Arizona State University, told Interesting Engineering in October 2025, 3. I Atlas is a comet from another solar system. It has only done cometary things. It has outgassed various species at just the distances from the Sun we expect them. Compared to solar system comets, it's got a lot of carbon dioxide relative to water, but these are exactly the sorts of gases we expect. Emitting nickel vapor is something we learned 5 years ago that comets normally do. This object has not done a non-cometary thing. Jacqueline McCleary, assistant professor of physics at Northeastern University, explained to Northeastern News in September 2025. Clearly, the 3 I Atlas parent system maybe was really rich in carbon dioxide, or maybe there were weird radiation processes that left a lot of carbon dioxide and boiled away everything else. It's a window into what the pristine material is for other solar systems, which is precious, and in turn helps us refine our models of what solar system formation can look like. Early observations showed 3I Atlas had what looked like an anti-tail, a spike of material pointing toward the sun instead of away from it. Some claimed this violated known comet behavior, suggested artificial structures, propulsion systems. The truth? Anti-tails are rare, but completely natural. We've seen them before. Appears as a spike pointing sunward. It's not actually pointing toward the sun, it's following the orbital path. We're just seeing it from an angle that makes it look that way. Comet Lulin in 2009 displayed an anti-tail visible through amateur telescopes. It's uncommon, but documented. Not evidence of anything except unusual viewing geometry. Gemini observatory images from August captured both the coma and a tail streaming away from the comet. That's solar wind and radiation pressure pushing gas and dust away from the sun. Standard comet behavior. The Nordic Optical Telescope caught dust and ice jets directed toward the sun between July and September. Also normal. These jets form when subsurface ice pockets heat up and explode outward. The rotation of the nucleus determines which direction they point. Sometimes sunward. Sometimes in other directions. Depends on where the active areas are located on the surface. The viewing geometry changed as the comet moved along its orbit. The anti-tail disappeared. The normal tail became more prominent. Exactly what you'd expect from natural comet behavior. No aliens required. Early estimates suggested 3I Atlas could be massive. Way bigger than previous interstellar objects. Some claims put it at 5 to 11 kilometers across with a mass exceeding 33 billion tons. That's 3 to 5 orders of magnitude, more massive than Oumuamua or Borisov. Sounds impressive, sounds unusual, but the numbers kept changing as better data came in. But images showed the coma's brightness accounted for a large fraction of the apparent brightness. That means the actual nucleus is probably at the lower end of the estimate. The estimated dust loss rate suggests the nucleus is likely less than 1 kilometer in diameter, like Borisov. The Swift Observatory suggested 4.94 kilometers based on water vapor emission area, but that measurement is likely an overestimate. Most of 3I Atlas's water vapor comes from the coma, not directly from the nucleus. The coma is the cloud of gas and dust surrounding the nucleus. It can extend tens of thousands of kilometers. Measuring the emission area gives you coma size, not nucleus size. Showed the coma diameter growing from 13,040 kilometers to 18,760 kilometers over 11 days. That's coma growth, not nucleus size. The nucleus itself is probably small. Hubble's detailed imaging constrained it to most likely less than 1 kilometer across. Calculate how much thrust the outgassing produces. Work backward to estimate mass, but this method has huge error bars. Small changes in the outgassing rate produce large changes in the calculated mass. It's an estimate, not a measurement, and it doesn't mean the object is artificially massive. Just that it's big enough to have significant gravity, while also losing enough mass to slightly alter its trajectory. That's 220 trillion tons, way more massive than the highest estimates for 3I Atlas. And Halley's is just a normal periodic comet from our own solar system. Size alone doesn't indicate artificial origin. We're cutting through the noise to show you what the actual observations reveal. Also, comment from which city you're hearing this from. We're using peer-reviewed research from teams at UCLA, Caltech, Harvard-Smithsonian Center for Astrophysics, and the European Space Agency, published between July and October 2025. Primary sources from the scientists doing the work. Not speculation, not clickbait, just documented facts. Now here's why the myth that 3I Atlas is alien technology falls apart under basic scrutiny. Not just from one angle, from every angle. Water at 2.7 micrometers, carbon monoxide at 4.7 micrometers. These are absorption and emission lines from actual molecules vibrating and rotating in specific quantum states. You can't fake this with metal or circuitry. The spectrum matches icy volatiles sublimating under solar heating. Nothing else produces this signature. Ice turns to gas. Gas carries dust, creates coma and tail. A spacecraft would need active cooling systems to prevent overheating, would show different thermal signatures, would not steadily brighten according to distance from the sun. They break apart. Borisov partially fragmented during its visit in 2019. Shoemaker Levy 9 broke into multiple pieces before hitting Jupiter in 1994. 3. Atlas shows no signs of unusual structural integrity. It's shedding material at rates consistent with loosely bound ice and dust. A spacecraft would need to be much more robust, would not lose mass so readily. Older than Earth, older than our solar system. It formed around a star that lived and died before our sun even existed. The composition reflects ancient stellar nucleosynthesis, low metallicity environment. This is a pristine remnant from the early galaxy, not a product of recent technological civilization. It's not based on detection rates of artificial objects versus natural ones. We've confirmed exactly 3 interstellar objects. All 3 behave like comets. All 3 show spectroscopic evidence of ice and dust. All 3 follow trajectories consistent with gravitational dynamics. Sample size 3. Artificial objects detected, 0. Natural explanation probability should be near 100%, not 60 to 70. Why not during the rise of complex life 600 million years ago? Why not during the Industrial Revolution 200 years ago? Random arrival time suggests natural origin. Targeted arrival would require prediction of when intelligent life develops. We've only been detectable by radio for about 100 years. One-Eye Atlas left its home system millions or billions of years ago. No way to time its arrival to match human technological development. If the comet were going to do something artificial, solar conjunction would be the perfect cover. Hidden from Earth-based telescopes, could maneuver unobserved, could release probes, could change course, but it didn't. GOES 19 weather satellite observed it during conjunction on October 21st. Still just a comet. Mars orbiters saw it on October 3rd. Still just a comet. When it emerged in mid-November, every telescope confirmed the same thing. Same trajectory, same outgassing, same spectral signature. No changes, no surprises. Published findings in October 2021 on Centauri Dreams. Conclusion? The thermal protection system mass makes it impractical with current technology. You need multiple heat shields, supporting structure, ballast mass to keep center of gravity aligned. For a spacecraft with a kick stage, the shield assembly mass exceeds the payload mass, makes the whole concept unworkable. About 0.07 astronomical units, uses a carbon composite heat shield, doesn't perform Oberth maneuvers, just studies the solar corona. 3. IATLAS reached perihelion at 1.4 astronomical units, 210 million kilometers from the Sun. That's almost twice Earth's distance, 14 times farther than Parker Solar Probe. The thermal environment at 1.4 astronomical units is not extreme. An artificial probe wouldn't need to hide there. Could approach much closer if it wanted maximum thermal assist. So why do the myths persist? Why does a Harvard professor continue pushing the alien hypothesis despite overwhelming evidence against it? Scientific consensus now, it was a comet or asteroid outgassing hydrogen. Loeb claimed to find fragments of an interstellar meteor in the Pacific Ocean in 2023. Said they might be alien spacecraft debris. Metallurgists analyzed the spherules. Composition consistent with coal ash or ordinary meteorites. The seismic signal used to locate the debris, caused by a truck driving near a sensor. Benjamin Fernando's team proved this in 2024. Get interviews on Good Morning Britain, Coast to Coast AM. Draw millions of dollars in funding. The Galileo Project raised significant money to search for alien artifacts. Publishers want sensational books, extraterrestrial. The first sign of intelligent life beyond Earth became a bestseller in 2021. Controversy sells. Careful science it doesn't. Every explained feature gets dismissed. The chemistry is weird? Must be artificial? The chemistry gets explained? Well, the trajectory is suspicious. The trajectory follows natural laws? Well, what about the size? The size estimates come down? Well, what might it do during solar conjunction? It does nothing during conjunction? Well, absence of evidence isn't evidence of absence. Published their rebuttal in July 2023. Read Loeb's book cover to cover, checked every claim. Conclusion? Under careful scrutiny, the claims are often incorrect. Little to no evidence that Oumuamua is an artificial object. Same applies to 3-Eye Atlas. Samantha Lawler, astronomer at the University of Virginia, told Live Science about the 3-Eye Atlas alien paper. While it is important to remain open-minded about any testable prediction, the new paper pushes the sentiment to the limit. Extraordinary claims require extraordinary evidence, while the evidence presented is absolutely not extraordinary. Daryl Selliman, astronomer at Michigan State University, who led the first study quantifying 3-Eye Atlas properties, told Live Science, there have been numerous telescopic observations of 3-Eye Atlas, demonstrating that it's displaying classical signatures of cometary activity. All evidence points to this being an ordinary comet that was ejected from another solar system, just as countless billions of comets have been ejected from our own solar system. This is only the third confirmed interstellar object in history. First was Oumuamua in 2017, discovered already leaving the solar system, couldn't study it in detail, gone before we could get good data. Second was Borisov in 2019, got better observations. Confirmed it was a comet, found it had similar composition to solar system comets, but still limited time. Multiple telescopes: Hubble, James Webb, Spherex, Swift, TESS, Mars Express, ExoMars, Trace Gas Orbiter. Europa Clipper might catch its ion tail. JUICE will observe from Jupiter. Unprecedented coordination. Our solar system's comets are mostly water ice, some carbon dioxide and carbon monoxide mixed in. But 3. I-Atlas is 8 parts carbon dioxide to 1 part water. That ratio tells us its parent system formed under different conditions. Maybe the parent star was cooler. Maybe the protoplanetary disk was carbon-rich. Maybe cosmic ray exposure was higher. We're seeing the fossil record of stellar chemistry billions of years old. Our solar system formed 4.54 billion years ago. 3. I-Atlas could predate Earth by 2.5 billion years. It's a time capsule from when the Milky Way was younger. Fewer heavy elements, different stellar populations. Ancient chemistry preserved in ice for eons. The velocity tells us about galactic dynamics. 209,000 kilometers per hour relative to the Sun. That's accumulated momentum from millions or billions of years drifting through the galaxy. Every close pass by a star added velocity through gravitational slingshot. Every passage through nebulae added or subtracted speed from drag. The current speed is the integrated history of every gravitational interaction over the object's entire lifetime, moving almost perpendicular to the galactic plane. These vectors let us trace back its galactic orbit, figure out which stellar populations it passed through, which regions of the Milky Way it called home. September 2025, study by Xavier Perez Coto at Universidade da Coruña calculated it passed within 1 parsec of 25 known stars in the past 10 million years. Couldn't trace it back to a specific origin, too many gravitational interactions, but narrowed the possibilities to the thin disk or thick disk. In a region so cold that even volatile ice is condensed. The chemistry reflects the temperature gradient of that long-dead protoplanetary disk. By comparing 3 I-Atlas to solar system comets, we test whether our system is typical or unusual. We learn what kinds of chemical environments produce planets, maybe even what kinds produce life. McCleary at Northeastern explained, it's a window into what the pristine material is for other solar systems, which is precious, and in turn helps us refine our models of what solar system formation can look like. Is our solar system common or rare? Hubble, scheduled to perform ultraviolet spectroscopy in November 2025. We'll determine sulfur to oxygen ratios, gas composition, monitor the comet on its way out. James Webb, scheduled for more observations in December after perihelion. We'll see what changed after closest solar approach. How much carbon dioxide boiled off? What's left underneath? Whether water becomes more prominent in the coma. Data won't arrive until February 2026 because JUICE is far from Earth on the opposite side of the Sun. But when that data comes back, we'll have observations from multiple distances, multiple angles. Complete picture of how an interstellar comet responds to our Sun. November 2025. 3. I-Atlas emerges from behind the Sun, visible again from Earth. Astronomers worldwide turn their instruments toward it, not to find alien technology, not to spot mini-probes, not to discover hidden maneuvers, to study the rarest kind of object we can observe up close, a visitor from another star system, a messenger carrying chemical information across light years, a piece of galactic history that formation around a star will never see. Accelerating as it climbs back out of the Sun's gravity well, passing Jupiter's orbit in March 2026, heading back to interstellar space. In a few years, it'll be beyond the range of our best telescopes, back into the darkness between stars, drifting for millions more years until random chance brings it near another stellar system. Or maybe it never encounters another star, just wanders the galactic disk forever, ancient ice carrying ancient chemistry through an ancient galaxy. But while it's here, while we can see it, we squeeze every photon of information from it, because chances like this come once in a career, maybe once in a lifetime. 3 I-Atlas, Oumuamua, Borisov, 3 confirmed visitors in 8 years. The Vera Rubin Observatory starts full operation soon. Legacy survey of space and time. We'll find more. Maybe 1 per month once it's running at full capacity. But each one is precious. Each one teaches us something we can't learn any other way. About stellar chemistry across the galaxy, about how solar systems form under different conditions, about the diversity of planetary building blocks, about whether Earth's ingredients are common or rare, about whether life's precursors exist throughout the Milky Way or only in special places. The real story isn't the myth, it's the science. And the science here is extraordinary. We're witnessing material that formed in another solar system billions of years ago, preserved in the deep freeze of interstellar space, delivered to our telescopes by cosmic chance. Outgassing in our sun's heat so we can read its chemical signature? learning what kinds of worlds form around which kinds of stars. Alien transmissions, hidden probes. Meanwhile, the GOES-19 satellite continues routine observations. Mars orbiters process their data. Scientists prepare for emergence in mid-November, not with fear, not with paranoia, with excitement about what the post-perihelion observations will reveal. The final data point comes from an unlikely source, not Hubble or Webb or any space telescope, from the deep ocean floor near Papua New Guinea. Except this isn't about 3, Atlas, it's about why we should trust the scientific process over sensational claims. In 2023, Loeb's team dredged the Pacific looking for meteor fragments, found magnetic spherules, claimed possible alien spacecraft debris. Meteoriticists analyzed them at conferences, pointed out they're consistent with coal ash, with ordinary meteorites, with terrestrial volcanic material, with World War II warfare residue in that region. In 2024, Fernando's team published seismology analysis, the signal used to locate the search area, not from a meteor impact, from a truck driving past a sensor. Sensational claim. Media attention, funding. Then careful analysis shows mundane explanation. But the retraction doesn't get headlines, the debunking doesn't go viral, the correction doesn't generate book deals. So the cycle repeats, new object, new speculation, new media tour. While actual scientists do the hard work of real observation and measurement and analysis. It's releasing carbon dioxide and water vapor and dust. The most interesting thing about this comet is what it actually is, not what it isn't. Another set of formation conditions, another data point in the vast experiment of planet formation across the Milky Way. That's the real discovery. That's what matters. That's what we'll remember long after the alien technology myths fade into forgotten internet threads. Scientists compile data. Reality triumphs over speculation, one peer-reviewed paper at a time. And somewhere in a future we'll never see, 3i Atlas passes within range of another civilization's telescopes, if they exist, if they're curious, if they have the technology to observe. And maybe they wonder the same thing. Is this natural or artificial? And maybe their scientists look at the spectroscopy, the thermal signature, the structural behavior, the chemistry, and tell their version of confused enthusiasts the same thing our scientists tell us,